Coming to mechanism of MPV reduction. Ketones with the aluminum isopropoxide is taken this way for convenience. Okay. One of the isopropoxy groups is taken out. Now, look at what happens. Aluminium being a Lewis acid is given a pair of electron, then this and this. Okay, that's interesting. Again, a hydride is attacking the carbonyl carbon. Now, what do we get? R, C, then R dash. Now, this oxygen is going to form a bond with going to give you a transition state. OCH Me2 taken twice. Now, this is a bond going to be formed. Then this bond is going to get broken. It's BB. Now, you have already got a bond here. A bond is going to get formed. Okay. This is bond formation. And now, look at this. This bond is going to get broken. We get a bond formed between these two. Okay. This is how it can be given. Right. Now, this simply decomposes. To form R, C, then R, O, Al, O, CH, Me2 taken twice. You got this hydrogen. Now look at this. Say this hydrogen is from aluminum isopropoxide, right? Very important. Along with that, see the thing what we are going to get is this area. CH3, because this bond is going to get broken and this bond is also going to get broken. So we end up with this CH3, C double bond O, CH. Okay. So that is the mechanism of MPV reduction, wherein ketones are reduced into secondary alcohol. Let me give you some examples. Okay. Now, when this is subjected to reduction, using isopropyl alcohol and aluminum isopropoxide. See, even in this case also, the double bond remains as such. It is not reduced. See this. This one is reduced. This is okay. This is not okay. Now, one more. Even in case of cyclic compounds. Okay. Then see the important point regarding this reduction is it is inapplicable in case of ketones with the high enol content. For example, very important, we can take beta diketones, even beta keto esters, where the enol content is very high. Okay. Coming to beta diketone, we can take this. It is pentane 2,4-dione, a diketone, with more enol content when compared to the beta keto ester. Okay. You can see the order of enol content in GOC. I mean the tautomerism part. Now, from esters by hydrolysis. See, in the hydrolysis of esters, we got two things. Acid hydrolysis of esters and basic hydrolysis of esters. Nothing but saponification. Let us first go for the acidic hydrolysis of esters. Okay. Now, even in this also, I have different cases. Let us check them out. If both R and R dash are smaller, see the ester can be given as R C double bond O R dash. Now, the first case is where the R and R dash are smaller. Let's see what happens. Very interesting. Look at this. So this is an ester. Acid catalyzed. We can just take this way. Okay. Now R, C, the double bond with a pair of electron, then this H. O, yes, of course, this is R dash. R dash. Now the attack of water. As and when this comes, this one goes towards the positive charge. Of course, the positive charge is nullified. Okay. Here we get this. Of course, the water molecule is used to remove a H plus. Okay. This one goes towards. Then we get RCOH, then O, R dash, and this, of course, is OH. Okay. Now, consider almost the same thing again with H plus. Now, here a proton is abstracted, RCOH. Now, this again is OH. Here you get O, R dash, and H, a positive charge. This is the most important step. See, as and when this comes here, this bond is broken. The most important step. Okay. Now that is how R, C, double bond O, a plus, then H, OH, and the R dash, OH are formed. So you got this very important step wherein the cleavage is called acyl oxy cleavage because a bond got broken here. Look at this area. Between the acyl group and the oxy is an atom. So we call it acyl oxy cleavage. So very important is when both R and R dash are smaller, the cleavage that happens is acyl oxy cleavage. Now, okay, making use of say water, you can just abstract a proton. And this one goes towards this. So that is how you get a course, yeah, this can be given in some other way. Uh, Now the pair of electron on oxygen is given. Even that way, we can remove R, C, double bond O. This is of course OH. But here in this case, R dash, O, H, this. Okay. Now here you can remove the H plus using a water molecule. So finally you get R dash OH. So the important point with regard to this is this. Okay. So when both R and R dash are smaller, acyl oxy cleavage occurs. This is the first case. Now let us see what if R is bulky and R dash is a smaller in the same ester. If R is bulky and R dash is smaller. Let's see what happens. Taking an example, the same acid catalyzed hydration. If suppose this happens, look at this. So this is the bulky R. Now, as a result, these two reactions never happen. This, the one that has to happen, and even this. It is because if that happens, we are going to get something unstable. This is very unstable, highly unstable. Because of the bulkiness of this group, this is highly unstable. And in this case, the interesting part is as the bulkiness of our group increases, the stability of this I mean, the intermediate what is formed during this reaction, that is the tetrahedral intermediate, goes on decreasing. See, as the stability of the intermediate goes on decreasing, no doubt the activation energy goes on increasing because it's not that favorable. You need more activation energy. As a result, rate of reaction goes on decreasing. So this is very important. As the bulkiness increases, stability of the intermediate decreases, activation energy increases, and finally, the rate of reaction decreases. Look at this. Now, in this case, first step, which is a slow step or a rate determining step, this is how the cleavage occurs. Let me give you that here the order is 1, even the molecularity is also 1. As I said here, I think you can see you don't have this reaction, this step. Now the simple thing that has happened is bond is broken between the acyl group and the oxygen. So here again it is the acyl oxy cleavage. A very important one. Now we get C double bond O plus R dash O minus. Take water molecule now. Now, as and when this attacks, okay, we get C double bond O, then O, H, H, a pair of electron and a positive charge. Now, as usual, you can do this way. This one. That is how you get the final product. Let me give it here. So we get C double bond O, OH plus R dash OH. Okay. So in the first two cases, what we have seen till now, it is the acyl oxy cleavage. Okay. Now let us go for the third case where the R group is smaller and R dash is bulky. This is interesting.